Hi, in this session we'll be discussing about sequences and series. This is the first topic in your fourth module, infinite series. Okay, so what is an infinite series? Okay, so infinite series is basically nothing but a summation of infinite number of terms. Okay, so far we have discussed in our lower classes summation of finite number of terms like 2 plus 3 plus 4 etc. So infinite series, in this summation you will have infinite number of terms. Okay, so we usually write it as some a1 plus a2 plus a3 plus etc plus an plus etc plus like this. Okay, so if there are infinite number of terms to be added, we'll call that call this expression as an infinite series. Okay, otherwise it is called a finite series. Okay, so why do we need to study infinite series? Okay, it's a very simple thing, because infinite you will study later on in this semester and also in next semester that we can use infinite series to represent complicated functions. Okay, some functions are very difficult to find. Okay, so but those functions could be approximated by using this infinite series to any degree of approximation. Okay, so in order to approximate some complicated functions, we will be approximating functions later on in the next module also, and also for solving differential equations, for calculating integrals and everything, this infinite series is being used. Okay, so why should we study infinite series in detail? The problem is that here we are actually dealing with infinite number of terms. Okay, so the usual rules of addition and other operations will not work in the case of infinite series. Okay, for example, I'll give you an example here. For example, suppose I have a series like this. For example, 1 minus 1 plus 1 minus 1 plus 1 minus 1 etc. Suppose this is my series. Okay, and now if I am going to add this series, I'm not changing the order or anything, I'm just going to add a series like this. Suppose I'm adding 1 minus 1 plus 1 minus 1 plus 1 minus 1 plus etc. What will I get? I'll get the answer as 0. Okay, and if the same series, I can also add in another way. Okay, I can also add in another way like this. Suppose I'll keep one as such. First I'll add the second and third term. So I'm going to add these two terms, then I'm going to add these two terms, then I'm going to add these two terms. So what will I get? So I'll be getting 1 plus 1 minus 0 0 0 etc. So the answer would be 1. Okay, so the same series, only by changing the way you are adding, you will be getting two different answers. Okay, so this means that such series are not very good. Okay, so they are not behaving properly. So we cannot use these type of series to approximate functions. Why? Because these type of series, when you are adding, you are getting different answers. So how will you use them to approximate functions? Okay, so there are some such problematic series in infinite series also. Okay, so we have to sort out the good series, or series which are behaving very good in a very nice manner. Only those series we will be using in the approximation and also in other calculations. Okay, so you will have to sort out which series could be used, which series cannot be used. Okay, so in order to study that, we will be studying more about series first. Okay, which are the well behaved series, which are not well behaving series, like this series which are giving different values when you are calculating. Okay, so that is what you are going to do. So before we start with infinite series and also try to find out which are the good series, we will start with a very simple concept called sequences. Okay, so we will start with a very simple concept called sequences, because the theory of infinite series could be reduced to sequences only. Okay, and what is a sequence? Sequence is nothing but an ordered set of numbers. Okay, or ordered set of functions, whatever it may be. So basically sequence is an ordered set of something. Okay, it is the only the difference. What is it's basically an ordered set. Okay, so okay, so let us start with sequence here. A sequence is nothing but a list of numbers written in a specific order. For example, I can write many sequence here. For I will write here as 1, 2, 3, 4, etc. This is a sequence here. Okay, so there can be finite sequence, infinite sequence. In this session, we will be discussing only infinite sequence, because finite sequences are actually very much easier. Okay, so we are only discussing infinite sequences here. So in general, the infinite sequences will be like some a1, a2, etc., an, etc. It will be going like this, where an is the nth term. Okay, so here is the general sequence. You usually write a general sequence in a shorthand form as, I'll write this as an. So this is the shorthand notation of a general sequence. Okay, can you give me some examples of sequences? So you can write many examples are there. You can write 1 by 2, 1 by 3, etc. Okay, 1 by n, etc. So can you you know that the nth term of this sequence is basically 1 by n, or I can write it in shorthand as this one. or this sequence, can you find out the nth term? The nth term of this sequence is basically n, so I can write in shorthand as n. Okay, so every sequence you can't find the nth term, so every sequence will not have a definite pattern like this, but most sequences which you encounter will have a definite pattern like this in this module. Okay, generally most sequences will not have a definite pattern like this. You can't find out the nth term. Okay, so that is not needed. I'm just telling you for your information. So these are some examples of sequences. Okay, so we have written some examples here. So this is the sequence n, this is sequence 1 by n. Okay, now can you tell me this is sequence 1 minus 1 1 minus 1. Can you give me a general expression for a n? What will be a n here? The first term is 1, the second term is minus 1, third term is 1. So for odd terms I am getting 1, for even terms I am getting minus 1. So how will I do? So you can write in many ways. I can say this as minus 1 raised to maybe n minus 1. That is one possibility. If you put n is equal to 1, you will be getting minus 1 raised to 0, which is 1. When you are putting n is equal to 2, you will be getting minus 1 square raised to 2 minus 1, which is again minus 1. Or you can write it as minus 1 raised to n plus 1 also. That is also another representation. Okay, so similarly, can you, so this is just 1 2 by 3. Okay, to make that correction, this is just something has been, okay, so just look at the sequence 1 by 2 minus 2 by 3, okay, 3 by 4 minus 4 by 5. Okay, I have just made a mistake writing the sequence here. Okay, just look at the sequence. Can you give me the nth term here? Or just before that, look at the sequence 1 by 2, 2 by 3, 3 by 4, 4 by 5, etc. Look at the sequence. Can you give me the nth term here? Okay, so if you look at the first term, it is 1 by 2, second term it is 2 by 3. So nth term it would be n by n plus 1, right? So first term you have 1 by 2, second term you have 2 by 3, third term you have 3 by 4. So look at the pattern. For 3 you have 3 by 4, for 4 you have 4 5 5, for n you have n by n plus 1. Okay, now look at the pattern of the sequence. So for odd terms it is positive, for even terms it is negative. Okay, so either you can put minus 1 raised to n plus 1 here, or just minus 1 raised to n minus 1 here also. Okay, so in that case your odd terms would become positive and even terms would become negative. Okay, so that is some ways of writing these sequences here. So that's it. Okay, you can also say that, so as I told you, your sequence is generally written as a1 a2 etc a3 4. So for number 1 I will have the term a1, for number 2 I will have the term a2, the third term would be a3. So you can see the sequences are actually functions from the set of integers. Okay, so basically sequence is basically a function from the set of integers. Okay, so it can be real numbers or complex or whatever may be. So basically sequence is a function whose domain is the set of integers. This is the mathematical definition. Just try to understand, like, there is no need to study anything. This is the basic definition. Okay, since sequence is a function, definitely you can talk of limit of functions. So we'll come to that now. So just as functions have limit, sequences also will have limit. We'll talk of that shortly. So before that, let us try to graph some sequences. Yeah, okay, let us give a sequence. We'll try to just draw the graph of that sequence like that. Okay, so look at this examples here. Okay, so look at close here. Look here, I am giving the sequence n plus 1. Okay, so this is the graph of that sequence. For 1 you have the value 2, for 2 you have the value 3. So it is going endlessly like this. So this is a one sequence. And if you look at this sequence here, minus 1 raised to n plus 1 here, so you can say that for 1 I am getting the value as minus 1, for 2 I am getting the value as minus 1 here, for 3 I am getting it as minus 1, 4 I am. So basically you can see that this sequence is oscillating. Okay, it is oscillating between positive and negative values. Okay, so you can see that this sequence is going to infinity. Okay, so such sequence we will say that they are diverging. Okay, so so many terms are there associated with this. Just try to understand this thing. So some sequences will go on to infinity, some sequence can go on to minus infinity, some sequences can oscillate like this. Okay, and here some sequences are, you can say sequence n by n plus 1, that is basically 1 by 2. If you write few terms, it is 1 by 2, 2 by 3. So this sequence has been mapped here. So if you look the terms of this sequence, you can say that they are actually going to approach, they are coming closer and closer to this red line here. Okay, what is that red line? That red line is value 1. So you can see that these numbers of the sequence is nearly approaching this value 1. Okay, so you can see that they are going closer and closer to 1 here. Okay, also in this sequence, which is basically 1 plus minus 1 by 2 raised to n here, Here also we can see that the sequence is actually oscillating only. So for 1 you have 1, okay, so for 1 you have 1 by 2, so again for 2 you will have 3 by 2, so it will be going like this, and it is actually going outside and inside, so it is going above 1 and coming down also 1, but actually it is approaching 1 as n goes to infinity here. Okay, so you can see that even if it is oscillating, it is actually approaching this one here. Okay, so you can observe that some sequences will tend to some finite value as n goes to infinity. Okay, so as the numbers increases, n goes to infinity means as the numbers are increasing, it is seem to be approaching some value. So in these two sequences you can see that case, but it is not true for these two sequences. So for some sequences, as n becomes larger, you can see that they are approaching some particular value. Okay, so such sequences are called convergent sequences. Okay, for example, this is a convergent sequence, this is a convergent sequence, because as the sequence grows bigger, it is approaching this value. Here also, as it grows bigger, it is approaching this value. So such sequences are called convergent sequences, otherwise they are called divergent. For example, this is a divergent sequence, and this is also divergent. We'll also call it as, if you want, you can also call them as oscillating sequences. Okay, so how sequences can be classified into convergent sequences and also divergent sequences. If you want, you can also classify them as oscillating sequences also. Okay, so usually we consider oscillating sequences as divergent itself, that's why I don't write that, but that's okay. Okay, so I hope it is clear. So some sequences are tend to reach as actually tend to cluster around as a finite value. Some other sequences will go on up to infinity. Some other sequences will be oscillating. Okay, and we will write this as up. So now we will be considering only convergent sequences. So I can write convergent sequences as sequences with the property that this limit n tends to infinity. So just look at this closely. Limit n tends to infinity, the nth term of the sequence is actually approaching some fixed value. So if you look at this one, this nth term of this sequence is actually approaching this 1. So I can write this limit n tends to infinity, an is equal to this 1. Okay, similarly, if you look at this sequence also, you can see that the nth term is actually approaching this fact value 1. Okay, but in this case, what is happening? The nth term, limit n tends to infinity, nth term has no finite value, it is actually infinity. Okay, and in this case we can see that nth term, it is actually oscillating, so it is, this limit will not exist. Okay, because we will one an plus 1 will have one value, an plus 2 will have another value, so the limit will not exist in that case. Okay, so we will only discuss convergent sequence which has the property that limit n tends to infinity, an is equal to L. Okay. So from now onwards, you will be given some problems, you will be given some sequences. You will be asked to find out whether the sequence is convergent or divergent, but by evaluating this limit and to find the limit of the sequence. Okay. So I hope it is clear. What do you mean by sequence? Sequence is nothing but basically it's an ordered set of numbers. Okay, or you can say that it's a function defined on the set of integers. Okay, and you can see that sequences can be convergent or divergent. What do you mean by convergent sequences? Those sequences which whose values tend to reach a or comes closer to a finite value, they are called convergent sequences. But if that doesn't happen, we will call it as a divergent sequence, and this is a notation for convergent sequence. Okay, we can also give a mathematically rigorous definition to it, but it is not required for you at this level, so I'll just stick on with this definition. Okay, that is enough. Okay, so moving forward, I hope it is clear. This L is said to be the limit of the sequence. Now let us try to do some problems related to it. Okay, so determine whether the sequence n by 2 plus n 2n plus 1 is convergent or not, and if convergent, find the limit. So here you will have to use the properties of limits extensively. You have studied about limits in your lower classes. We will be using this. So in order to check whether a sequence is convergent or not, we will just evaluate this quantity, limit n tends to infinity an, and if it has a finite value, we will say that the sequence is convergent. Okay, so now look, here already the sequence given to you is n by 2n plus 1. If you want, the sequence is basically 1 by 3, 1, then 2 by 5, etc. Okay, so how will you check whether this is convergent? Just put limit n tends to infinity n by 2n plus 1. Okay, so how will you find out the value? So how will you calculate infinite limits? Limit n tends to infinity n by 2n plus 1. How will you calculate infinite limits? One way is you can take out the maximum value of n from both numerator and denominator and try to cancel it out. So what is it? It is actually limit n tends to infinity. The maximum value of n numerator is n and denominator the maximum power is n. So we will be getting it as 2 plus 1 by n. Okay, you have studied this in your lower classes. Your n gets cancelled out. So this is actually limit n tends to infinity 1 by 2 plus 1 by n, which is nothing but 1 by 2 because your 1 by n is 0. Okay, so you can you have got that limit n tends to infinity a n exists and its value is 1 by 2. Okay, and similarly, suppose your sequence was just like this 1 by n. Okay, so how will you calculate? It is nothing but limit n tends to infinity 1 by n, no higher power of n in the numerator, only n is there in denominator, so it will be simply be 0. Okay, so suppose it is actually limit n tends to infinity. Suppose your sequence is maybe n square minus 1 by n cube plus 2n plus 2. How will you do it out? Take out the maximum power of n from the numerator, take out the maximum power of n from the denominator and see what is happening. So it will be simply n square into 1 minus 1 by n square divided by, okay, then you will have n cube 1 plus 2 by n square plus 2 by n cube. Okay, so you will be getting this as your n square will get cancelled and n will be remaining here. So when you apply the limits, your 1 by n square will become 0, this will be 0, this will be 0, and you will be ultimately having 1 by n in the denominator, so the value will be 0. Okay, or in other words, suppose your sequence is n square plus 2 by n minus 1. What will be the limit of the sequence? You take the maximum power of n outside, so it will be simply n square into 1 plus 2 by n square into n into 1 minus 1 by n. So 1 n gets cancelled out. So now if you apply the limit, what will happen? This 2 by n square will be 0, 1 by n square will be 0, but this n will be lying there, so you will be getting the value as infinity. So this is how you usually calculate infinite limits. We will be doing some more problems also, but I hope the concept is clear. Okay, so this is the idea. Okay, so now let us look at some problems here. So what is the limit of this one? Limit at sequence 8 minus 2. So we have to check whether this is convergent or not. So it will be limit n tends to infinity 8 minus 2n. So what is it? So it is actually 8 minus limit n tends to infinity 2n. Now this goes to infinity, so this is actually equal to minus infinity, or so it is actually convergent. They are divergent. You are not getting a finite value. So this is actually divergent series. So straight away you can write here also, but it is okay. So that is why. So you have to just calculate limit n tends to infinity a n. Now you have got that. You will not get a finite value in this quantity because n is lying in the numerator. Okay, so this is not convergent. Okay, now let us now look at the next question. Minus 1 by 1 raised to n plus 1 by 1 by n. Okay, so what is it actually? We can see that limit n tends to infinity 1 by n. We're just looking at the positive values, it is actually 0. So even if it is oscillating, what is happening? The values would actually be going to 0 only. Okay, so even if you are taking 1 comma minus 1 by 2 plus 1 by 3 minus 1 by 4, you can see that each of the terms are actually going to a 0 itself. Okay, so even if this is oscillating, what is happening is as n grows bigger, this an actually goes to 0. Okay, so it doesn't matter whether it is positive or negative, it is going to 0 only as n grows bigger. So this is actually convergent and the value is actually 0. Okay, if you look at the sequence here, n by 2 n plus 1. So if you look at that sequence, what is that sequence? That's actually 1 by 3, okay, 2 by 5, okay, 3 by 7, etc. So since there is minus 1 raised to n plus 1, so it will be 1 by 3 minus 2 by 5 plus 3 by 7, again minus 4 by 9, etc. Okay, now what is the limit of the sequence? First let us look at limit n tends to infinity a n. So it is actually 1 by 2, right? So you will be getting this as a limit n tends to infinity n by 2n plus 1 is actually limit n tends to infinity, take n outside here also 2 plus 1 by n, so you will be getting the value as 1 by 2. But the problem here is that the odd terms would be going to just positive 1 by 2, while the even terms would be going to minus 1 by 2, because even terms contain a negative factor. So odd terms are going to 1 by 2, even terms are going to minus 1 by 2. So that means this sequence is oscillating. Okay, so therefore it is not convergent. Okay, you can write it like that itself. So it is not convergent. Okay, so you can say that the odd terms converge to 1 by 2, the even terms converge to minus 1 by 2. Therefore the sequence does not exist. The limit of the sequence does not exist. Okay, so moving forward, can you find out the limit of the sequence? So here an is not given to you. You can write on an. What is an here? So it is nothing but 1 by 2 raised to, it is actually 2 raised to n plus 1 only, but I'll just write as 2 raised to, okay, if you want, you can write 1 by 2 raised to n plus 1. Okay, it's no issue. Okay, it is 1 by 2 raised to n plus 1. It is not n plus 1, sorry, n minus 1, right? Okay, so 1 by 2 raised to n minus 1. Okay, so it is 1 by 2 raised to n minus 1 only. Okay, now what is the limit of the sequence? It is simply be limit n tends to infinity 1 by 2 raised to n minus 1. Now tell me what, so here you cannot use the other approach, but just use your common sense here. What will happen if n goes to infinity? The denominator will become infinity, and therefore this will become 0. Okay, so just by using our common sense, you can see that as n goes to infinity, 2 raised to n minus 1 grows bigger and bigger, and it goes to infinity, so the value which will be just be 0. Okay, so that is another way. Okay, and if here is one more question for you. So what is this limit? You have to find the limit of the sequence. Please try to do it yourself. So it is actually limit n tends to infinity 1 minus 5n raised to 4 by n raised to 4 plus 8n cube. So how will you do it? As I told you, take out the largest power of n outside, so it is n raised to 4 in the numerator, so 1 by n raised to 4 minus 5 divided by n raised to 4 1 plus 8 by n. Okay, so when you cancel it out, what will you get? So this will get cancelled out, your 1 by n raised to 4 becomes 0. Okay, so you will be getting the answer as actually minus 5, because 8 by n is also 0, so the value of the limit is actually minus 5. Okay, so I hope it is clear. Okay, and one more question here, n square minus 2n plus 1 by n minus 1, what is it actually? That is actually, if you want, there are many ways there. So limit n tends to infinity, take out n square from numerator, it will be 1 minus 2 by n plus 1 by n square divided by n into 1 minus 1 by n. Okay, so one n is cancelled out, so here 1 by n is 0, but there is a factor of n in the numerator, therefore this will actually become infinity. Or you can see that this is actually n minus 1 whole square by n minus 1 itself, so it will be simply be limit n tends to infinity n minus 1. So in that way also you can calculate the limits. Okay, I hope it is clear. And moving forward, so let us look at some more questions here. So I'll discuss one useful result here. Sometimes it will not be easy to calculate limit in this format. Okay, sometimes it will be difficult to calculate. So in that case, if you consider the function f of x in place of fn, so consider fn is equal to some f of n. So for example, here your fn is actually 8 minus 2. Suppose you are consider this nth term as some f of n. Okay, if you replace this f of n by f of x, and if you can find the limit of f of x, it will be the same as this f of n. Okay, so that is the idea here. So we are going to replace in some problems, not in every problem. Some problems it will be easier if you can switch from f of n to f of x, because you know to find the limits of f of x through many ways, like the many techniques are there to find limits of f of x. You have studied in a lower class like L'Hospital's rules. Okay, then there are some say squeeze theorems. How many theorems are there? We will come to that later, but using those techniques you can easily calculate this limit. So we will be trying to use those techniques in the next section now. So it will be easier to consider the function f of x in place of a sequence f of n and find its limits using methods like L'Hospital's rule. Okay, the geometrical justification of this is that, so you can say that the limit of the sequence, so you can say the sequence is actually the points here. You can see the points here, so the limit of those points would be the same as the limit of the function itself. Okay, so if f of x goes to L as x tends to infinite, definitely f of n also will goes to L as n tends to infinite. So because of that reason, instead of finding the limit of f of n, we can find the limit of f of x. Okay, for some problems it will be easier in this way. Okay, not in every problem, we will see that now. Okay, so let us look at one question here. So look at this question. So limit n tends to infinity, we will have to find limit n tends to infinity n by e raised to n. Okay, if you know the value it is okay, but it is not easier to find out what happens because both n is going to infinity and e raised to n is also going to infinity, so it is infinity by infinity form here. So directly you can't apply in f of n. So if you consider this function as f of x, this quantity will be in infinity by infinity form, so we can apply the L'Hospital's rule there. Okay, so if your f of x here is actually x by e raised to x, so limit x tends to infinity, f of x is actually, it is limit x tends to infinity x by e raised to x. What is it actually become? So this is an infinity by infinity form, so we can use so using L'Hospital's rules, you have to take the derivative of denominator, so derivative of numerator, so it is 1 by derivative of denominator is actually e raised to x itself. So now it is not in 0 by 0, not in infinity by infinity form, so when you apply this quantity, what will you get? You will be getting 1 by e raised to infinity, which is infinity, so the value will be 0. Okay, so very simple thing. So the value of this quantity, by considering f of x, I can obtain it as actually 0 by using L'Hospital's rule. Okay, so that is the method. Okay, so very simple thing. Okay, so similarly we will do one more question here. Can you find out the limit of this one also? Okay, so here also if you consider, it is actually limit n tends to infinity log n by n. So you can see that as n goes to infinity, it is coming to infinity by infinity form. So directly you cannot find it out. So you just take f of x. Here f of x is actually log x by x. So limit x tends to infinity, log x by x is actually 1 by x by 1. Limit x tends to infinity, 1 by x by 1. So what is it actually? So this will become 1 by infinity, which is nothing but 0. So the value of this quantity is actually 0. Okay. Similarly, if you look at this question, how will you do this question? Here you have to find limit n tends to infinity n plus 1 by n minus 1 raised to n. Okay, so how will you find it out? If you want, you can take the function x, so it will be, instead of this we can find limit x tends to infinity x plus 1 by x minus 1 raised to x. Okay, so before you look at this question, you can actually tweak it a little bit. If you have studied infinite limits earlier, if you have studied limits earlier, if you look at this quantity here, your f of x is of the form x plus 1 by x minus 1 raised to x. Okay, so if you by x raised to x, okay, if you consider log of f of x, it will be easier to evaluate. So it will be simply be x log of x plus 1 by x minus 1, right? So if f of x has, if this has a limit L, log of x will have a limit log L. That's the only difference. So you have studied this in your lower classes, so it will be easier to evaluate this limit here. Okay, so f of x has limit L, log of f of x would have limit log of L. So let us try to evaluate limit of this one. So let us try to evaluate limit x tends to infinity x log x plus 1 by x minus 1. Okay, now what is this actually? If n x goes to infinity, this will become infinity, right? Infinity in the log of infinity plus 1 by, so basically in this case it will be like, so if you look at this closely, it is actually log of x into 1 plus 1 by x by x into 1 minus 1 by x only. So this, when x goes to infinity, you will be getting this as log 1, so this will become 0. So this is of the form infinity by 0 form. Okay, so you cannot use L'Hospital's rule directly, so you need to make it either 0 by 0 form or infinity by infinity form. Only then you can use L'Hospital's rule. So you can study this in your lower classes. So this I can write this as limit. So how will I have what, which is the easiest way to do that? So it will be simply be limit x tends to infinity. If I write this as log x plus 1 by x minus 1 divided by 1 by x. Okay, now this will become of the form 0 by 0 itself. Okay, because it is easier to take x to the denominator. So now this is of the form 0 by 0, and you can use the L'Hospital's rules in this case. Okay, so what is it actually? So I'll write once again. We are considering the function x log x plus 1, okay, by x minus 1 here, log of x plus 1 by x minus 1 here. So instead of we'll take log of x plus 1 by x minus 1 by 1 by x to make it a 0 by 0 form, and then we'll apply the L'Hospital's rule. Okay, so what is L'Hospital's rule saying? So you have to take derivative of numerator by derivative of denominator. Okay, so please try to find out. So it will become limit x tends to infinity. Now log of x plus 1 by x minus 1 could be written as log of x plus 1 minus log of x minus 1. So it is easier to take derivative if you write in this format. So it will be simply be 1 by x plus 1 minus 1 by x minus 1. This is the derivative, right? So this is actually x minus 1 minus x minus 1 by x square minus 1. So it is actually minus 2 by x square minus 1. So derivative of that is actually minus 2 by x square minus 1, and derivative of 1 by x is minus 1 by x square. Okay, so it is minus 2 by x square minus 1 by minus 1 by x square, or in other words, if you just make it clear, make it simpler, it will be limit x tends to infinity 2x square by x square minus 1. Okay, now it is easier to evaluate if you take x square outside, just like our previous cases. It will be simply be limit x tends to infinity x square into 2 by x square into 1 minus 1 by x square. So you will be getting the value as 2. Okay, so I hope it is clear. So two things are there. You had f of x, you took log f of x to make computation easier. Once you took log of x, you made a slight rearrangement here to make it out the form 0 by 0. Okay, these are all techniques we have done in L'Hospital's rules there. So it is nothing new here. Only thing is that we are recalling all those methods here. Okay, so nothing new has been learned, just the familiar limit which you have learned in your lower classes. Okay, and now you can use the L'Hospital rule here by taking derivative of numerator by derivative of denominator. So we took derivative of numerator in a much easier way, because here it is easier to evaluate in this format. So we found out the limit was minus 2 by x square minus 1. Now we apply the limits and then you will get the answer as 2. Okay, so limit of log f of x was 2. So what is limit of f of x? So it will simply be e raised to x. Okay, so limit of f of x will be simply be e raised to this limit, which is e square. Okay, so in order to eliminate this log, you have to take e on both sides. So it will be simply be e square. So limit of f of x is e square, or in other words, limit of this quantity is actually e square. Okay, so that is clear. I hope that is also clear. Okay, so please try to do this problem by yourself. You are using all the techniques of limits here. Okay, that's it. Okay, moving forward, so I'll give you some examples of some useful limits which you can use in your later classes. Okay, so please go through these examples. You may have seen this before. Anyway, we will be using these limits in the infinite series portion. Okay, the proof is not required for you, but please look at these identities, familiarize yourself, and then we'll be using it in the lower classes. Okay, so next classes. Okay, so I hope it is clear. So something you can always usually use. You can prove most of them by L'Hospital's rules also by other techniques also you can prove it, but it's not required for you. Just look at this limits and try to be familiarized with these limits. Okay, so that's all for today. Thank you.